In this video, we'd like to introduce the concept of work in physics and how to calculate that. There is an equation to actually calculate work. Work, what is it? Well, work is when you take a force and you apply it to an object and you move that object a certain distance. So we could have a box here, we'll say, on the floor. And if I come down here and I apply some kind of a force to it, and if you haven't talked about forces too much, there's a couple units you can use. Generally what we use in physics is newtons of force. I could say I applied 4 newtons of force to this box. Now sometimes you might see another unit, sometimes you might see pounds of force. You have a certain weight. Your weight is a force. If you stepped on someone, you would be applying a force to them of whatever your weight is. So you could say that you have so many pounds of force, or you could convert that to newtons and talk about newtons of force. Either one will be okay. So I apply a certain force to this box, and the box then moves a certain distance. And the important thing for work is that work is only being done if the force and the displacement d are in the same direction. They have to be in the same direction. So the way we calculate work is force, and we'll put force parallel because it has to be in this parallel direction as the displacement. So force times d, F times d. That is your equation for work. Force times d. Well, what are the units for force? Well, I just said they could be in newtons. And the units for displacement, usually if we're in the metric system, is in meters. And so the unit for work could be what we call a newton meter. And normally we don't leave it that way. We convert, or we talk about what a newton meter is. And a newton meter is 1 joule. So usually work is, or energy, work is a form of energy, are in joules, capital J. But sometimes we can leave it in newton meters. We will especially leave it in those units if, like you had this be in pounds, your force in pounds, and your distance may be like in inches, then your work would be in pounds inch, pound inches, or something like that. And we would a lot of times just leave it in those terms. I like to do newton meters or joules because that's kind of the metric system, and that's what we usually use in science. But if you're in POE, they might still use some of the English system, and that might be pounds, inches. You just got to watch and make sure you know which one you're in. Okay, a classic question is, what if I have a weight, and let's say the weight of this is I don't know, some kind of a weight. Normally what we call this weight or this force is Fr, which stands for the resistance force. A resistance force. A weight is a resistance force. It's resisting you. And let's say I want to lift this force up a certain height. I want to lift it from here up to like there. I want to move it that displacement. How would I do that? Well, I would have to apply a force to it, and I'd have to apply it in this direction. And that force that I'm going to apply to lift this is also a force. It'd still be in newtons, like the resistance force would be. But we usually call this the effort force because it's the force that you're putting your effort into. You're doing that. So that would be your effort force. Effort force. And I would have to, of course, make that, if I wanted to go with a nice constant velocity, I'd apply the same amount of force as what the resistance force is, and I would move this object up, and if I took this effort force times this displacement, they're in the same direction, then I would have the work. I'd be able to calculate the amount of work. So, to lift something, I would have to apply the same amount of force as whatever it weighed, whatever its resistance force is. So let's think about this. Let's say I have a certain resistance force, and I want to I want to lift it up a certain displacement, and then I want to walk over this way a certain displacement, and then I want to go up higher, another displacement. How much force would it take? Well, I would have to apply my effort force to it and move it a certain displacement up, and I would multiply those two together, and that would be a certain amount of work. But how much work does it take for me to walk over this way? Well, if I'm just carrying this box, so let's say we have this little person here, and this person carries something upwards, and then he walks over this way. Well, he's still applying the force upwards on the box, but he's moving it this way. So, a lot of times people are tempted to take whatever that force is times this displacement. Why can't you do that? You can't do that because work is force parallel to the displacement, and this force is not parallel to this displacement. So even though you're walking over this way, you're applying the force upward still to hold the box, you are doing no work. This wouldn't even count. We're not doing any work here. Now, once I start lifting it up again, I would be applying my force upwards always for this box, and now that I'm moving upwards in that direction, that displacement, then I would be doing work again. So I would calculate work here, I'd calculate work here, but this would not be any work. Okay, so that is your equation for work. Hopefully you can remember that, and it's very important that the work equals the force parallel to the displacement that you are applying the force. And that's the introduction on force.